guys, welcome back to class. We are going to continue our series on function transformations. So we did the exponential functions. So now we are going to do the inverse of that. Remember, opposite operation. We're going to do the inverse of that with our logarithmic functions. Okay, so just like before, I'm going to go over all the traits of the parent function, and then I will talk about how to transform them. Okay, so if your parent function is log base b of x, remember all that means is we can make our base anything we want. Okay, and then the x is our argument. The domain of a logarithmic function is from 0 to infinity, and the range is from negative infinity to infinity. Okay, remember anytime you see this negative infinity to infinity, when you are transforming that, that doesn't change. You can't stretch infinity. You can't bump infinity up, down, right, left. It stays infinity. Okay, so we don't have to worry too much about that one. Instead of a horizontal asymptote like we have in exponential functions, we will have a vertical asymptote now. Okay, so vertical asymptote. Remember that needs to be in an equation form, so that will be x equals 0. Our intercepts, there is an x-intercept now, no y-intercept. There's an x-intercept, and it will be at 1, 0. So that'll be a point that we can shift around when we transform. All right. Um, and then if you want to know just some points that you can keep in mind for your parent function, 1, 0, that's your x-intercept. And then if you place b, whatever the base is, as your x value, you'll always get out 1. If you do 1 over b, you'll always get out -1. Again, those points can transfer. Okay, so let's take a look at our mild, medium, and spicy examples. Remember, the only thing that makes things spicy in these particular problems is the fact that you're just adding more transformations on. Okay, so this first one that we have is we have the log base 2 of x plus 1 minus 3. All right, so our parent function is going to be log base b of x. It's a logarithmic function. And then we're going to be even more specific because we know what our base is. Our base is 2. All right, so the first thing that we're going to do is we're going to go through and we're going to see what do we hit first. Okay, so the first thing that I notice is a plus 1. And when I say what I notice, remember that means that I'm saying that what is different between my parent function and the function that I have transformed. So the first thing that I notice is that plus 1, and ask myself the questions. Is it acting on the parent function as a whole? So is it out in front or out behind? Or is it acting on the x, which most of the time means it will be in parentheses, all right? This is acting on the x, so that means it is horizontal, and I am adding. Okay, addition and subtraction mean that you are shifting, so that's going to be your up, down, right, left. Horizontal means I'm going to go right or left. That means my x's are crazy, so plus 1 means I am going to the left 1 unit. Okay, so that is my horizontal shift. Then, see what else is different? I see this -3. That's the next thing that's different. Okay, it is acting on the function as a whole. It's not inside the parentheses. It is acting on the logarithm as a whole. Remember, that's my parent function. So since it's acting on the whole thing, I know that that means vertical. It is also adding or subtracting. In this case, it's subtracting. So I know that that is a shift. It's going to go up or down, right? And in this case, since it is -3, that means we are going to go down 3 units. All right, those two things are the only things different between log base 2 of x and rf of x. Okay, so our range, I'm going to jump to that one because we know that one doesn't change. Our range is going to be from -infinity to infinity. Can't change that one. Our domain, however, if we take a look at this, our domain has moved because we took our entire parent function. Remember, here's a picture of our parent function. We took our entire parent function and we shifted this whole thing to the left 1 unit. So I'll even show you how that works. I am going to change the color of that and watch this. I am shifting this. So you see that red dotted line is the asymptote for the parent function. I'm going to take the blue line and I'm going to shift it 1 unit to the left. Okay, so when you shift right or left for logarithmic functions, that changes your asymptote. So in this case, and your domain. So in this case, our domain shifted 1 unit to the left. So instead of being from 0 to infinity, it will be from 1 to infinity. Okay, and again, we just talked about that asymptote, so I'm going to go ahead and write this. This will be at x equals -1. And I need to make this a -1 as well. Sorry, we're going from -1 to infinity. Intercepts, all right. X-intercept, remember when you were looking for the x-intercept, that means that we will find f of x equals 0. So we're going to set our function equal to 0 and solve. So if I set this guy equal to 0 and solve, I am going to get the log base 2 of x plus 1 minus 3, and that is going to be equal to 0. I'm going to solve this logarithmic function. So I will add 3 to both sides, and then I will have log base 2 of x plus 1 equals 3. I have my logarithm by itself, so I am going to change this to exponential form. So this will be 2 to the third power equals x plus 1. And then last but not least, I will subtract 1 from both sides. So 2 cubed is 8. 8 minus 1 is 7, and that equals my x value. So my my x-intercept, sorry, is 7, 0. So that's the point that that's a point that I'm going to plot to help me. Okay, so I'm going to come over here and I'm going to plot that point. So I am going to plot 1, 2, 3, 4, 5, 6, 7, 0. Okay, so I know that that's a point that I'm plotting. All right, like I've done in the past, I gave you some values for your parent function. So I have 1/2, -1, 1, 0, 2, 1, and 4, 2. And what I'm going to do is I'm going to show you what those transformations do to that point. All right. So our x values, well, what happens to our x values? Our x values are just shifted to the left 1 unit. Remember, that means that we are going to subtract 1 from them to move it to the left. So I would do 1/2 minus 1, so that's -1/2. I would do 1 minus 1, and I would do 2 minus 1 and 4 minus 1. So I have, again, -1/2, I have 0, I have 1, and I have 3. Okay? Then we're going to look and see what happens to our x values. I'm sorry, our y values. Our y values have a vertical shift down 3 units. So we're going to subtract 3 from every one of our y values. So that means that I will have -1 minus 3. Again, I'm taking all of these y values and subtracting the 3. So I'd have 0 minus 3, I'd have 1 minus 3, and I'd have had 2 minus 3. So -1 minus 3, -4, -3, -2, -1. So I'm going to plot those points. So I have -1/2, -4, -1/2, -1, 2, 3, 4. So everything got shifted. The next one, 0, 3. So 0, 3. So if we look, that's 1, 0. And look, remember, we're going to shift it 1 to the left to 0, and then down 3. 1, 2, 3. Boom. Okay. I'm going to stop there. You can plot all of those points, as many as you want. But remember, then we're going to shift down and go that way. Okay. So that is our shifted logarithmic function. Okay. Let's take a look at a spicier one. Now I have medium. All right. This is -2 log base 7 of x minus 4. All right. So again, it's a logarithmic function. We know what the base is. So our parent function is log base 7 of x. Okay. So transformations, as I see them, the first one that I see is this minus sign. Remember, that is going to be a reflection. Okay. And we just have to ask, is it acting on the logarithm as a whole, or is it just acting on the x? Again, you'll usually be able to tell this by parentheses. Since it is not inside the parentheses, it is acting on the logarithm as a whole. This is going to be a vertical reflection. Okay, then what we're going to have is the next thing that I see. I see this 2 right here. Okay, again, it is acting on the logarithm as a whole. It's not acting on just the x. So we know that is also going to be vertical. And it is multiplying times the whole logarithm. Since that's multiplication, that is going to be a stretch by a factor of 2. Okay. Remember, stretches for vertical stretches are anything that's greater than 1. And then last but not least, what I have is I have my -4 value here. Okay, that is acting upon the x. All right, it's not acting upon the logarithm as a whole, it's just acting on the x. So that is horizontal. Since we are subtracting, that means it is a shift. And your x's are crazy. So instead of going to the left, we're going to go to the right 4 units. Okay, so those are our shifts. Those are our transformations, right? Going to our domain and range, I'm going to skip down to my range again because that's the easy part. Our range isn't going to change. It is going to stay -infinity to infinity. All right, our domain did change because again, I'm going to do the same thing I did on the last one. If you take your asymptote that is for the original function at x equals 0, we shifted everything to the, we shifted everything to the right 4 units. So that means I'm going to take this asymptote and I'm going to shift it 1, 2, 3, 4. I shifted it to the right 4 units. Okay, so if you want to go ahead and do that with your asymptote, that means your asymptote is now at x equal 4. So that also shifts your domain, right? Your domain is going to get pushed along with it. So instead of being from 0 to infinity, our domain is going to be from 4 to infinity. And then intercepts, again, we're not going to have an x-intercept. I'm sorry, a y-intercept. We're going to have an x-intercept. So we're going to set our function. So we're going to look for our x-intercept. Remember, that means f of x equals 0, or whatever the name of the function is. This one is h of x. But we're going to set -2 log base 7 of x minus 4 equal to 0. And we're going to solve this guy. Okay, so I will divide everything by a -2, and I end up with the log base 7 of x minus 4 equals 0 divided by -2 is 0. I have my logarithmic function by itself, so then I can change to exponential form. So I will have 7 to the 0 power equals x minus 4. And then I will add 4 to both sides. 7 to the 0 power is 1. 1 plus 4 is 5. Again, don't ever be afraid to use your calculators for this kind of arithmetic. You don't need to know how to do all of this in your head. Certain parts, you just write them down when you can. Okay? Equals and x. So that means that my x-intercept is going to be 5, 0. All right, so I can go ahead and plot that point. So I'm going to plot the point 5, 0. That guy right there. Okay? Then again, I'm going to take some of these points that I already have. These are points that are along the parent function. Those points will be transformed. All right. So easiest one to transform that I'm going to do, I'm just going to do one of them this time, is the 1, 0. So it is a vertical reflection, a vertical stretch, and then a horizontal shift. The horizontal shift just means you're going to do 7. Oops, I said I was going to do the x-intercept. I'm going to take 1, and I am going to add 4 to it. If I add 4 to it, that shifts it to the right 4 units. So that gives me my 5. And then for my 0, I am going to reflect it, and then I am going to stretch it. So I'm going to multiply it by a -2, essentially. So it'll be -2 times 0, which is still 0. So we get our new x-intercept. I'll do one more point just to show you I have another point to plot. So I'm going to take this guy right here. So 7, and then I'm going to add 4 to it. So I shift it 4 units to the right. That will give me 11. And then my 1, I am going to reflect and stretch by 2. So that ends up being -2 times that 1, which is still negative, which is -2. Okay. So I am going to plot that point 11, -2. I'm going to be slightly outside of my box here. This would be 11, and then -1, -2, be like this. Okay. Remember, when you reflect this over the x-axis, which is what we're doing, that vertical reflection, it's going to end up flipping over, so it's going to look like this. Okay. So that's why our picture will start way up here and then start turning, which we need to make that. There we go. Okay. And there is our shifted picture. We shifted it over, we stretched it out, and then we flipped it. Okay. All right. So there's our medium one. We got one more to go. Let's go spicy. All right. Spicy. Again, all you're doing to make things spicier is adding more transformations. The more transformations you do, it doesn't really make it harder. It makes more things that you just have to be aware of. Okay. So going through, like we have been, I have that negative sign first. The reason I do the negative first is because it's the first thing I saw. So that is a reflection. It is acting on the logarithm as a whole. All right. The base is 2. So this is our parent function, log base 2 of x. So we know that we are going to have a vertical reflection. Okay. The next thing that I come across is this negative sign. So we're going to have another reflection, except notice that this one is now inside the parentheses. It's acting on this x. So this is a horizontal reflection. Right? The next thing that I come across is this guy right here. This is 1/2. All right. This 1/2 is also acting on the x. It's not acting on the logarithm as a whole. Again, if it acts on the logarithm as a whole, you're either going to see it way out in front or way behind. That 1/2 is multiplied, so that is going to be a horizontal stretch. The reason I call it a stretch is your x's are crazy. So even though this number is between 0 and 1, it's the opposite of what we think. So instead of multiplying by 1/2, we're going to divide by 1/2, which is actually stretching our x values out. Okay. So that takes care of that guy. We have still something left over on the inside. We still have this -1, so that is acting on the x. It's not acting on this logarithm as a whole. So -1, that is a horizontal shift. X's are crazy, so it's opposite of what you see. -1 is really going to be to the right 1 unit. Okay, and we're not done yet. Again, the only thing that makes this spicy is we're just going to keep adding transformations. This last one we have is a +3. That is acting on the logarithm as a whole. Notice it's outside of this logarithm. So that means it is going to be a vertical shift. Y's never lie, so it will be up 3 units. So those are all of our shifts. All right. Going down to just the basics that we can cover. So range is our easy one because remember, it is not going to change. It's -infinity to infinity. All right. Our domain will change because of a horizontal shift. If you stretch a vertical line, it doesn't change at all, okay? A line is a line is a line. If you shift it up, it doesn't change it. If you reflect it, it doesn't change it. What moves a vertical line is going to be this horizontal shift. We're moving it right and left, okay? We've moved it to the right 1 unit. So remember, what that does is that takes our asymptote. We're going to do this part again. We're going to take this asymptote and we are going to, made it a different color, we're going to shift it to the right 1 unit. Boom. So since we shifted that asymptote to the right 1 unit, that will also shift your entire function to the right 1 unit, which shifts your domain to the right 1 unit. So this will go from 1 to infinity. Okay. Asymptote, we just talked about, that moved to x equal 1. Intercepts, we're going to do the same thing that we've done. We are going to find our x-intercept, so we are going to set negative log base 2 of -1/2 x minus 1 plus 3 equal to 0. So we have to make all of that equal to 0. So I'm going to start by subtracting 3 from both sides. So that gives me negative log base 2 of -1/2 x minus 1 equals -3. Then what I'm going to do is I'm going to divide this whole thing by a -1. That gets rid of this negative here. So I end up with the log base 2 of -1/2 x minus 1. And that'll equal a +3 now because we divided that side by a -1 as well. I'm going to transform this into exponential notation since I have my logarithm by itself. That means I have 2 cubed equals -1/2 x minus 1. I'm going to add 1 to both sides. This is what makes it spicy and complicated is you just have a little bit more algebra work to do. Okay? This ends up being 8 plus 1 is 9. So we have, oh, running out of room. I'm going to do it over here. I have 9 equals -1/2 x. So then to get rid of that, because again, we don't like to deal with fractions, I'm going to go ahead and multiply this whole thing through by a -2. That takes care of the negative and it takes care of the 1/2. So this ends up being -18 is equal to x. So our x-intercept is -18, 0. I won't be able to graph that in my smaller graph, but you'll see where it goes. Okay. So we have reflected this. So I'm going to come back here because I did make a mistake. We reflected our, we did this horizontal reflection, so that also messes with the domain. So I made a mistake on that, so we're going to come back to it and I'll fix that one. Sorry about that. Okay. So here's what we're going to do. We have negative 18, 0. We know that's way over there, but we're going to transform some of these points. All right. There is an order of operations to transforming your points. So that's why I want to go through some of these. Okay. So for our x values, we will first, what you do is you shift them first. Then you stretch and reflect. Okay, so shift first, then shift and reflect. So I'm going to take 1 and I will shift it first. So I'm going to shift it 1 to the right. So I'm going to add 1 to it, and then I'm going to multiply it by the stretch. Okay, I'm multiplying by a 2 because I would really divide, right? We do the opposite operation because our x's are crazy. So what I'm really going to do is I'm going to divide by -1/2. Dividing by -1/2 and multiplying by 2 mean the exactly same thing. Okay, so this ends up being 1 plus 1 is 2. 2 times -2 is -4. Okay, so again, we're going to do this one too. I'm going to do -2 times 2 plus 1. Again, I'm putting this in parentheses so I know to do that part first, and then I'll do the reflection and the stretch. So 2 plus 1 is 3 times -2 is -6. So those change those 2 points. Okay. For our y values, we are going to first reflect and stretch them if we needed to, and then we will do vertical shift. So we get to follow order of operations for that one. So we're going to do -1, that's the reflection, times our y value, and then we're going to push it up 3. So that's still 0, 3. And then -1 times 1 plus 3, that's -1 plus 3, which is going to be 2. So 1, 0 transforms to be -4, 3. 2, 1 transforms to be -6, 2. So -4, 3 is my first point that I'm going to plot. One, 2, 3, 4. 1, 2, 3. And -6, 2. 1, 2, 3, 4, 5, 6, 2. And did that again. All right. So again, order of operations. So I'm going to go over this because in my brain. So order of operations, you have to shift. This is for your x values. This is order of operations for your x values. You shift, so right or left, then you reflect slash stretch slash shrink, whichever one it is. Okay, whichever one. So you've got to do that, those two, you've got to do the shifting first. So we shifted our points and then we reflected them and stretched in this case. All right. So that also happens to your asymptote, right? Because we would need to shift it and then reflect it. So if you shift your asymptote, show you picture. If you shift your asymptote to 1 and then multiply it by a -1 to reflect it, it's going to go here and then shift right back over to here. Okay, so that's why that's where our asymptote is. So I needed to fix that for you guys. So this is really x equals -1. All right, and I told you I messed up on the domain, so this is where I'm fixing it. This is from -infinity because we did the reflection, so it flips -infinity to -1. Okay. So if we take our parent function, If we reflect it over the x-axis, right? If we reflect it over the x-axis, that means it's going to end up looking like this. But then we're going to flip it again over the y-axis. So we're going to end up looking like this when we flip it. Okay, so I have these 2 points here. If you need to plot more points, please don't be afraid to plot more points. You are absolutely going to be able to do that. So I'm going to go up like this. And there is my graph. Okay, I messed that a little bit. If you want me to do another example, I am more than happy to do that. But this is the shifting of the logarithmic functions. Okay, take your time, don't rush through them, and let me know if you need more specific examples, different examples. Leave a comment about it, like the video, subscribe, and I will see you guys in class next time. Bye.